Hello everyone. In this video, we'll understand about the algorithms and the flowcharts. So algorithm is defined as an effective procedure for solving a problem in a finite number of steps. So before writing a program, we first write the algorithm, decide what data is required, and then we write the program. So given any problem, we first write the algorithm for it, and then we write program in any of the programming languages. So basically, a program is an algorithm plus a data, right? Algorithm is also considered as a part of your computer program. Okay. Now this algorithm, it has few characteristics, like algorithm must be unambiguous. The steps that you write in an algorithm, they must be unambiguous. There should not be any ambiguity in the steps. It should be written in a stepwise manner, step 1, 2, 3 and so on. The number of steps in an algorithm must be finite, that is, they must be countable. The next characteristic is that it might accept a set of inputs. In an algorithm, you might specify the input required, but an algorithm, it should specify what is the output out of this algorithm, right? So a problem, it might take an input or it might not take an input, but however, there should be a desired output. After producing the result, the algorithm must terminate. So you should not have an infinite number of steps in an algorithm. Now, how do we write these algorithms? Algorithms are written in English-like statements. Okay. If at all there are any expressions, we incorporate the mathematical expressions too. Okay. Now let us understand how to write the algorithms by taking a simple example of finding sum of two numbers that are entered by the user. So in this particular problem, what will be the input? Input is the two numbers, and what is the output? The output is the sum, right? Now, always the algorithm will have the first step as stop and the first step as start and the last step as stop. Okay. Ask the user to enter two numbers. Read these two numbers into A and B. Now, if you observe, the steps are very clear. They are unambiguous. Fine. Compute the sum. So we have an addition operator as plus. Okay. In an algorithm, instead of using an assignment operator, we use an arrow mark. We can as well write this expression as C is equal to A plus B, where C, A and B, these are called as variables. Or they are also called as placeholders, right? They are also called as placeholders. So in this particular step, we are computing the sum of A and B and storing it into a variable C. As we discussed, the sum is the output, so which is stored in C, that must be printed. Stop. So if you just observe this algorithm, the steps are unambiguous. They are written in stepwise manner, 1, 2, 3, 4 and so on. The number of steps are finite, it's countable. It is accepting an input. The algorithm has an input statement and it has an output statement, right? We'll understand the algorithm by taking one more example to find the quotient and remainder of a division operation when the dividend and the divisor both are integers. Okay. Now here also, what will be the input? Input is the dividend and the divisor. Okay. The output is quotient and the remainder. Right. So start. Ask the user to enter a dividend. Read it into a variable n. Ask the user to enter a divisor. Read it into d. Compute n by d. Okay. So this operation will give us the quotient. Next, compute the remainder. R is equal to n minus q into d. Print R as well as q. So here print R and q, stop. So again, if you observe the algorithm, the number of steps are finite, the steps are unambiguous, it is written in stepwise manner, it's accepting an input and it's producing the output. One more example to exchange the numeric values of two variables. So start, we are making use of a temporary variable here. You can slightly modify and ask the user to enter the values of a and b in one sentence. Read the two values a and b. Okay, this can even be written as read a comma b, right? Next, c is equal to a. I mean, here c is used as a temporary variable. It's used as a temporary variable. Okay, so what happens here? The value of a is stored into c. Let us assume a is equal to 5 and b is equal to 6. Okay, so what we are doing here, we are using one temporary variable in order to swap the two values of the numbers. Okay, so here the value of a, that is 5, is assigned to c. Then a is equal to 6. Fine, a is equal to 6, b is equal to c, so b is equal to 5. So by end of this algorithm, we have exchanged the values of a and b, right? Print a and b, end or stop. Okay, so how does this program is reflected in the memory? In the memory, you have the label a along with its value, variable name b along with its value. So c will be used as a temporary variable. These are the initial value. After exchanging, we will have 6 and here we will have 5. Okay, now coming to the flowchart. Flowchart is basically a pictorial representation of an algorithm. Now in algorithm, we write the process in a stepwise manner using English like statements, but in case of flowchart, we make use of symbols. There are various shapes available in order to represent the flowchart, like box, circle, connecting arrows, and so on. Basically, flowchart help the programmer to understand the flow of control from one process to the another process. Alright, now the various shapes that are available for us are oval, that is used to indicate the beginning or end of the algorithm. Parallelogram, it indicates the input and output information. Rectangle, it is used to represent the processing. Rhombus for decision making. Hexagon for repetition, whenever we have looping, right, wherein we repeat certain instruction, we make use of hexagon. Now if at all you have modules or functions in the program, we make use of a lined rectangle. Okay, that basically represents a subprogram, a function, or a module. Connecting arrows to indicate the flow of control, and we use a circle here. Okay, we also use a circle in order to connect the various arrows. Okay, using these symbols, we'll understand a couple of examples. So the first one, to find the area of rectangle, right? As we had in our algorithm the start and stop, here also we do have start and stop, but we represent them in different symbols, right? We use ovals. Then in order to find the area of rectangle, we need the input as length and breadth. We read it from the user, put it into a parallelogram. So parallelogram represents your input and output. Okay, processing we carry out in our rectangle. So area is equal to length into breadth, which is computed inside this rectangular box. Right, Flowchart to swap two numbers. We just saw the algorithm with respect to it. The same thing when we put down in a flowchart. How does it look like? We have start and stop in oval, read A and B in parallelogram, processing C is equal to A is equal to B, and B is equal to C, which is there in your rectangle. Print the swapped values using parallelogram. Alright. Now find the algorithm and flowchart. Write the algorithm and draw the flowchart to find largest of three given numbers. Okay. How will this algorithm go? So you need to read three numbers A, B and C, right? Compare A and B. If A is greater, see if A is also greater than C. Then if it is true, A is the largest, otherwise it should be C, right? Now the other condition is A might be smaller than B. In that case, okay, compare if B is greater than C or less than C. If B is larger than C, then B is the largest number, otherwise C is the largest number. Okay, this is how we compare the values of three numbers. Now if I just put it down in the flowchart, how will I do it? Okay, so I have start, read three numbers A, B and C. I have put it into a parallelogram. Now the first thing I have to check, I have to make a decision here. So I have put the condition inside a rhombus. Is A greater than B? Always rhombus will give me two result, a true or a false. If it is true, okay, I need to make one more decision here. If it is greater than C, check if A is greater than C. If it is true, then print A is largest or A is biggest. Okay, after this I will go to the stop, I will go to the end. Now if it is false, obviously C might be, when C is the largest number, right? Now if A greater than B was false, then obviously B is the greatest among A and B. Now check if B is greater than C. If it is true, B is the largest number, otherwise it must be C, right? Once printing the result, whether A, B or C, whichever is the largest number, we end at this point stop, right? Hope this video has convinced you with respect to algorithms and flowchart. Thank you.